now that you know how to build a Pascal triangle, we're going to talk about the generalization of the binomial theorem. Okay, so how does it work? Well, this notation, it looks a little bit intimidating, so I'm going to just break it down for you. Okay, so the first term usually is going to be n, the combinations from n to 0, x to the power of n. N is the exponent here. Okay, and the second one that we have here, and this one is going to be degree n. Okay, so that you depend on the exponent over there. The second term is going to be n and 1. Okay, close it. Then you're going to have the a. Okay, in this one it's going to appear. The exponent of the a is 1. The exponent of the a is 0 here. That's why it doesn't basically appear. It's a 1. Okay. So over here you have that it's going to be x to the power of n minus 1 plus dot 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 dot, and then you have that it's going to end at, let's say, well, this is kind of like the middle, and j, let's call it j, a, j to the power of j, x to the power of n minus j, plus dot 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 dot. Okay, and then you have that the last term is going to be combinations from n to n of a to the power of n. Okay, because the x is going to be to the power of 0. Okay, now here's the secret. The exponent of these two terms, when you add the exponents, it always needs to add to n. Here this is the only exponent, so it's n. This one, remember, it's a 1. What's 1 plus n minus 1? N. Okay, so the next following, if you are imagining what would be the next one, it would be this one. Let me just put it here. It would be this guy. Okay, you would have that it's a, x, and minus 2. Do you agree with that? That would be the next one after this one, and so forth. Okay, so when you add the exponents, what happened to plus n minus 2 is n. Same here. Okay, so that's basically the secret. Okay, so this is when we apply the generalization of the Pascal triangle. Okay, we're going to do some examples just so you can understand better. Okay, this one is the binomial coefficient. Why it's a coefficient? Because it's a number. Remember, what is the coefficient? It's the companion of your variable. Okay, we'll go with that. So why this happens? Because you know that the combinations from n to j are the numerical coefficients that appear in the expansion of x, in this case x plus a to the power of n. Okay, so you have x plus 2 to the power of 5. Okay, so what are you going to do when you want to use the binomial theorem? Okay, so we have that this is going to be equal to combinations from 5 to 0, x to the power of 5, plus, and then you have 5, 1. Okay, so that's what you have over here, kind of like the same. Okay, and now what's going to change? You have that it's going to be, well, this is the second part of your 2 to the power of 1 times x to the power of 4 plus 5, 2 to the power of 2, x to the power of 3. As you can notice, the exponent of the 2 is increasing, the exponent of the x is decreasing. Okay, so we're going to see one pretty cool pattern in a second. Okay, once I finish writing this piece. Okay, so you have 5 to 3, and then you have 2 to the power of 3, x to the power of 2, plus 5, 4. Okay, 2 to the power of 4, x to the power of 1. Okay, you can put the 1 or not, it's up to you. Plus 5, 5, 2 to the power of what? 5, x to the power of 0, so I don't need to write it there because I know that it's a 1. Okay, so what do you notice? Certain patterns. The x's, or the first term, is going to be 5, 4, 3, 2, 1, 0. Okay, now, on the other hand, the second term that we have here, it starts with nothing, exponent 0, 1, 2, 3, 4, 5. So it's pretty easy to see the pattern if you are organized. Okay, so now you're going to tell me, what am I going to do with this? Well, you know that it's a number, so that's what we are about to do. Okay, so you know that 5 to 0, it's going to be 1 times x to the power of 5. Okay, plus you know that 5 and 1, it's going to be 5 times the 2 that you have over there times x to the power 4. Plus you know that combinations from 5 to 2, it's going to be what? 10. Okay, 10 times 2 to the power of 2 is 4, x power 3. Plus combinations from 5 to 3, that you know that it's going to be 10 again, times 2 to the power of 3. 2 to the power of 3 is 8, okay? And times x squared plus 5 and 4, you know that 5 and 4, it's going to be 5, times 2 to the power of 4 is going to be 16, times x, plus 5 is going to be 1, times 2 to the power of 5 is going to be 32. Now let's simplify this, okay? Okay, so you have x to the power of 5 plus 2 times 5, 10, x power 4 plus, you have that this is 40, x power 3 plus 80, x power 2 plus, you know that 5 times, what's that, times 16 is going to be another 80, x plus 32, and that's it, okay? And that's your expansion. I didn't FOIL, I just follow the Pascal triangle, and that's what I was doing at the beginning, okay? So nothing too magical, I was just following this, okay? So we are going to do this one, okay? It's a little bit more tricky because your first term is going to be the whole thing, 3 and y, not only y, it's going to be 3y, okay? So you're going to see that it's pretty simple if you use the parentheses, okay, and follow the same idea. Note that the exponent here, it's smaller. Of course, the number that I'm going to start with, it's smaller. It's going to be 4 to 0 instead of 5 to 0. Okay, then you have that you are going to start with your first term, which is 3y, and everything needs to be to the power of 4. That's why I'm putting the parentheses. Okay, then you put 4 plus 4 to 1, and then everything to the power of 3 times the 2. Okay, you know that it's going to be to the power of 1 plus 4 to 3y power 2. Okay, then you have the 2 power 2. Remember the exponents. I'm going to show you another pattern here once I finish writing this one. 4, 1, and you have that it's 3y to the power of 1, 2 to the power of 3, and last but not least, this is a 3, excuse me. Okay, and then you have that this is 4, 4, and then this is going to be 2 to the power of 4. Okay, so when you have this situation, okay, what happens here? Okay, another thing that I want you to note, that we didn't talk about that here, but it doesn't matter. The exponents here, okay, they always add to the exponent that you have over here, meaning the only exponent that you have here is 4, so it's the same. What exponents do you have? This is a 3 and this is technically a 1, so when you add it, it gives you 4. Here, what happens? 2, 2, 4, 1, 3, 4, 4, 4. Okay, so it always needs to match with the exponent of your original. Are we okay with that? So that's how you can double check, okay? Basically kind of triple check. Okay, so the combinations from 4 to 0, that's 1 times, and then you have that the 3 to the power of 4 is going to be 81, okay? Y power 4. Why? Because this 4, using properties of exponents, it's affecting the 3 and the y, okay? So please note that this is affecting both, okay? Same here and so forth. Plus, you have that this is going to be, what? It's going to be 4 times, and you have that that's going to be 27, y power 3 times 2, plus, and I'm going to simplify it, okay, in a second. Well, combine it more than simplifying it. Okay, this combination is going to be 6 times, you know that this one is going to be 9y squared times 4, plus, you know that this combination is going to be 4, okay, times 3y plus 2 times 2, 4 times, not plus, times 8, I don't know what I was thinking there, plus 1 times, and you know that that one is going to be 16. Okay, so when you do your combination here, 1 times 81, 81y power 4, plus you have that it's 216y power 3. Okay, plus you have that this times this times this. Okay, that one is going to be 216y power 2. This one you have that it's basically 12 times 8. Okay, yeah, which is 96. okay, y plus, and then the last one is going to be 16, and that's it. Okay, so that's your expansion here and here. Okay, any questions on that one? Hopefully not. Okay, so the binomial theorem also helps you to find the particular term in an expansion without having to write the entire expansion. Okay, so based on this expansion that we have, the general one, we're going to call it x plus a to the power of n. The term containing x to the power of j is going to be the following. Please note that this is a j. I know that it's super small here in the video, but it's a j. Okay, so what you have is going to be n, okay, and minus j combinations from that, and then it's going to be a n minus j times x to the power of j. Okay, so this is going to be the formula, another very important formula. I would put star there. Okay, remember this is combinations, okay? So that's for that. Now, let's use the binomial theorem, okay, to find this. Find the coefficient of y to the power of 8 in the expansion of 2y plus 3 power 10. Please note that this term is going to be together. That's going to be super important, okay? So with the formula, we need to recognize several things. You know that n is going to be to the power of 10, okay? Why? Because that's the exponent that you have, okay? Secondly, you know that your a is going to be what? 3. Technically, what you call x. X is going to be your 2y, okay? And j, the one that you want, the one that we want, 8. It's going to be 8. Okay, now applying the formula, now that we can recognize everything, it's super simple. Why? You have that it's going to be 10 minus 8. Okay, that's going to be a number. Remember, we're going to have the combinations of that. Then you have, okay, if you want to apply the formula exactly as it is, parentheses 3 to the power of 10 minus 8 times 2y to the power of 8. Okay, please note that the power of 8 is affecting the first term. Okay, so this is going to be equal. We simplify it. Okay, so you know that this is going to be the combinations from 10 to 2. Okay, so you have that it's going to be 3 to the power of 2. Okay, 2 to the power of 8 and y to the power of 8. Please remember that we distribute that exponent. Okay, that's from algebra 2, but I know that some of you just get distracted doing that. Okay, so you can do this the long way, or you can simply, let me teach you how to cheat. Use your calculator. Okay, if you go to your calculator, what are you going to do? Menu. You go to probability. I know it's weird, but it's there. Okay, and you're going to choose combinations. Okay, in this case, your combinations are 10 and 2. So you put it in order, 10, 2, and boom, you have the 45. Are we okay with that? So that's going to be the value that you want for this situation. Okay, so you just plug the 45. I don't know, you want it here. Okay, then you have this situation. Okay, so what do you have? You have that it's 45 times 9 times, I'm going to put 2 to the power of 8, right? And you have this humongous number. Okay, so you just copy that. Okay, 880, and then y to the power of 8. Oh, that number is huge, and makes sense, right? You have a 2, a 3, and power 10. Well, makes sense. Okay, so what can you conclude? The coefficient, okay, of y to the power of 8 is what? Okay, is since they are talking about coefficient, the coefficient is just the number, right? So the coefficient is going to be this guy. Okay, remember, what's the coefficient? The companion of the variable. What's your variable?